In this video, we are going to discuss indices. The word index refers to powers. For example, we have a number 2 which is being multiplied by itself 3 times. How will we represent this in powers? Now the number, you'll have to see how many times it's being multiplied by itself. Here it's being multiplied by itself 3 times. So in terms of power, we'll say this is 2 to the power of 3. And this is, the 3 in this case can be called a power or it can be called index. Now 2 is the base in this case and 3 is a positive power. Now if you have a number like 3 to the power of 4, this will mean 3 is being multiplied by itself 4 times. 2 to the power of 3, when you calculate it, will give you 2 to the 4, and 4 2s are 8. This gives you 8, and 3 3s are 9, 9 3s are 27, 27 3s are 81. So 3 to the power of 4 gives you 81. Now these two were the numbers with positive indices, positive powers. 2 was raised to the power of 3 and 3 was raised to the power of 4. If you get a question for a negative index like 4 is being raised to power minus 2, the way of calculating the numbers with negative powers of or negative indices is to convert them into reciprocals. Like, let's say, to make it general, we have a is being raised to the power of minus n. So this can be put in this form: 1 over a to the power of n. Following this rule, we can put 4 to the power of minus 2 into 1 over 4 to the power of 2, which is equal to 1 over 16, because 4 to the power of 2 means 4 times 4, which is 16. So when you have a negative index, you are going to make it into a reciprocal and then power it by the number with the minus symbol. Okay. Next we have the power of 0. Now any number, let's say we have a that is a variable, it can be any number, it is being raised to power 0. The answer to such numbers will be 1. 4 raised to power 0 is equal to 1. 3 raised to power 0 is equal to 1. 100 or 1000 even raised to the power of 0 will be equal to 1. Next we have rules of indices. Now if we have the same number with different powers and you have to multiply them, like 4 is being multiplied by 4, they are the same numbers but they have different powers, like 4 to the power of 2 times 4 to the power of 3. So without opening them up or expanding them up like this, 4 to the power of 2 means 4 times 4, and 4 to the power of 3 means 4 times 4 times 4. And then you calculating that, like 4 4 is 16, 16 4 are 64, and so on. Without doing all that, when you have the option of giving the answer in the form of indices or powers, then what you are going to do is simply add the powers up. Like 4 to the power of 2 times 4 to the power of 3 will give you 4 to the power of 5, because 2 and 3 makes, summing up makes 5. Now once you have expanded that all like this, even in this case you can see 4 is now 4 multiplying by itself twice being multiplied by 4 multiplying by itself thrice makes up all 4s being multiplied by themselves 5 times. So we get the same answer. So rather than expanding them all, like in this case here, you can simply add the powers up and find out the answer. And this will be much easier. This method will be a great relief for you when the question is in different forms like this. Let's say 2 to the power of 19 times 2 to the power of 7. So now you're not going to expand them up like 2 times 2 times 2 times blah 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 19 times, and then multiply, put the multiply symbol, and then 2 times 2 times 2 like 7 times, because this will take a lot more time. And if there's a much bigger power than this, you might as well calculate them wrong. So simply the answer will be 2 to the power of 19 plus 7, that makes 2 to the power of 26. Now here, the thing which you need to remember is that the powers of the numbers which are the same, when they are being multiplied, only then will you be able to use this method. Like the bases in this case, they are the same and the powers are different, only then will you be able to use this method. Like 4 to the power of 3 times 4 to the power of 7 makes 4 to the power of 10. But you can use that with different bases, like 3 to the power of 4 times 4 to the power of 2. Here you cannot use this method because the bases are not same in this case. The base here is 3 and the base here is 4. So here this method is working because the base here is 4 and the base here is also 4. So the general rule for all this will be a number being multiplied by the same number. It has both, one has the power of n, the other has the power of m. The answer will be the same base, the same number to the power of the sum of n and m. This will be the general formula you have to follow for finding out the questions which have the same basis but different powers. Now, what if divisions are involved rather than multiplications? For example, if you have a question like this, which has the same base 4 to the power of 7 divided by 4 to the power of 3. If you expand this all in this form, like 4 to the power of 7, 4 times 4 times 4 times 4 times 4 times 4 times 4 over, that means it's being divided by what? This is being divided by 4 to the power of 3, which is 4 times 4 times 4. Now if we cancel 4s out, 1 4 with 1, the other with the second, the third with the third, what are we left with? 4 to the power of 4. We are left with 4 being multiplied by themselves 4 times, because others are cancelled out. This will be equal to 4 times 4 times 4 times 4, which gives you 4 to the power of 4. Now if you remember the last methods which we were doing was that when we were multiplying the numbers with the numbers that had the same basis but different powers, their powers were being added up. Like here, 2 and 2 were being multiplied. One has the power of 19, the other has 7. You add them up. 4 has the power of 3 here and 7 here. You add them up, it makes up 10. Now if you come back to this division, here you see that something similar is being done, except that here we have a division symbol and there we got a multiplication symbol. Now, and this gives us the answer of 4 to the power of 4. Now doing another calculation like this, 2 to the power of 3 divided by 2 to the power of 2, which gives you 2 times 2 times 2 to the 2 to the power of 3, and divided by 2 to the power of 2, which is 2 times 2. You cancel 1 2 with 1 and the other with the second one. Now you're left with only 1 2. That means this is equal to 2 raised to the power 1. Now in this question, what we see is that 4 to the power of 7 was being divided by 4 to the power of 3, and there is a relationship between 7, 3 and 4 in this case. We can see that 7 minus 3 makes 4, and in this one as well, 3 minus 2 makes 1, and both had the same bases. Like 4 was divided by a number which also had the same base as 4 but different power, and in this case also we had the same base, 2 and 2, but their powers were different. So since their powers are different but bases are the same, we can use the method of subtracting the powers and making out the answer. That means we can use the general formula, the general equation for this rule, that when you have the same base, like a to the power of x, which is being divided by another number with the same base but different index, okay, a to the power of x being divided by a to the power of y will give us a to the power of x minus y. Now we can have some questions on it, on these rules, to simplify some expressions. Let's say we have an expression 4a to the power of 2 multiplied by 3b to the power of minus 3 multiplied by 2x to the power of 0. Now what we will do is we will multiply the numbers with the numbers, and if you remember the rule that the negative power will cause the base to become the denominator, like it becomes the reciprocal. So what we'll do is the first step is multiply the numbers. 4 times 3 times 2, 4 times 3 gives us 12, plus times 2 gives us 24, so you get 24. Now 24 a, there are no other a's, so we can't add the power of a's by multiplying, because if you remember, if you have the same base but different powers and the numbers are being multiplied, you can add the powers, but there's no other a, so we simply multiply a here, a to the power of 2 Then we have b, but b has the power of 3, which is negative, it's not positive. So b has to become a denominator. It will be reciprocated, but the power will remain the same, and once you reciprocate it, the minus symbol will disappear. And 2, okay, the number was had already been multiplied. Now we are left with x to the power of 0. Now x to the power of 0, if you remember, in the equations, in the rules we wrote here, any number to the power of 0 gives us 1. By following that rule, x to the power 0 gives us 1. This simply gives us the answer 24a square over b cubed. We might as well come across some equations which are exponential. That means their exponents, the powers, we can say the indices, are unknown. For example, we have 3 to the power of a, which gives us 81. Now the question is asking us of what shall 3 be powered by to become 81. So in this case, the first step shall be to make 81 in the form of 3's power. Now 3 raised to the power of what makes 81? To find a, we'll have to put 81 in the form of the power of 3. So this requires prime factorization. So one way is like drawing 2 lines like this and using the smallest as small prime numbers as you can, which the number can be divided from. Now here we can use 3 3 2s are 6, 2 carries, and 3 7s are 21. Here you get 27. Now we get 3 9s are 27, again divided by 3. The 3s are 9, again 3 1. We have factorized it all. That means 81 can be put in the form of 3 times 3 times 3 times 3, which gives us 3 to the power of 4. That means 3 to the power of a is equal to, we have factorized 81 in the form of 3's power, it becomes 3 to the power of 4. So 3 to the power of a is equal to 3 to the power of 4. So if 3 and 3 both are the bases and they are the same and equal in an equation, so the powers will therefore automatically will be the same. Here a is equal to 4. You can have a question like this as well. 2 to the power of b gives us 32. Again, we have to make 32 in the form of powers. Like we have to show 32 in the form of 2's powers. That means again we have to use the factorization method to see how many times 2 has to multiply by itself to make 32. 2 1s are 2, 1 carries 6 here, or 12. 2 16s are 32, 2 8s are 16, and 2 4s are 8, 2 2s are 4, 2 1 is 2. Okay, that makes 2 times 2 4, 5, 4 times 2 8, 8 times 2 16, 16 times 2 32. So 32 is equal to 2 to the power of 1 2 3 4 5. So 2 to the power of b is equal to 2 to the power of 5, because 32 is equal to 2 to the power of 5. Here now bases are the same again, so the powers will automatically be equal. That means b is equal to 5. You might come across a question like this as well. 4 to the power of x plus 2 is equal to 64. Now again, 64 has to be factorized. 64, it is, we can, now here what we shall do is we can use prime factorization. We can use 2 and but in this case we can also use 4 to make it easier, because we want to find 64 in terms of 4's power. That's why let's use 4 here. 4, how many's are 64? 4, 1 is 4, 2 carries 4, 6 are 24, 16. Again 4, how many are 16? 4, 4's are 16, 4, 1 is 4. So that means 4 times 4 times 4 is equal to 64. So that means 4 to the power of 3 is equal to 64. So here we get 4 times 4 to the power of x plus 2 is equal to 4 to the power of 3. So bases are the same again. They're equal. That means the power will also be equal. X plus 2 makes is equal to 3. If x plus 2 is equal to 3, that makes x equal to 3 minus 2 is equal to 1. Here therefore x is equal to 1. And that's how we will calculate such equations.